Try, adapt, learn. In this video, we will take a quick look inside a 12-volt 5-pole starter solenoid. If you haven't already subscribed, don't forget to subscribe now for more videos including DIY, maintenance, projects, and yard work. Starter solenoids help to make starting an engine very convenient. Before we take a look inside, let's take a moment to talk about how they work. As seen, this diagram shows a simple electrical circuit of how a starter solenoid can work. Although these diagrams may not use standard symbols, I'm sharing them to help illustrate how the parts function. While we look at this simplified electrical circuit for the starter solenoid, we will start with some vocabulary. Please keep in mind that for this video, we will keep the vocabulary and explanation simple. As mentioned in a previous video, a switch can be used to open and close an electrical circuit. For circuits with a lot of electrical current, a relay can be used. Instead of passing high current through a switch, a relay can make use of a low current switch to help open and close a circuit with high current. A solenoid can include a coil winding such as copper to produce a magnetic field with electrical current. So in this video, when we're talking about a starter solenoid, we're describing a part assembly that contains a solenoid and functions like a relay. Depending on the manufacturer and retailer, they will also use terms like pole, post, or terminal to describe the amount of electrical connections that can be made to the starter solenoid. The starter solenoid in this video is independent and can be mounted separately from the starter motor. The purpose of the starter solenoid is to transfer the current from the battery to the starter motor. Rather than send all that current through a switch such as the ignition switch, the assembly uses that switch by working like a relay. And how it does this is the solenoid inside the assembly creates a magnetic field that will pull a momentary switch to close the circuit. When the switch is open, the solenoid will lose its magnetism and the momentary switch will open as well. As we look at the outside of the assembly, we can see how this 5-pole got its name from the 5-pole post or terminals. You'll notice in this view the 5th pole is in the rear of the assembly. We also notice that what makes this 5-pole starter solenoid unique is that the 5th pole is specifically grounded to the solenoid. Please disregard this jumper wire that was previously installed. Although it functioned as the machine was delivered, it was unnecessary if the starting circuit was properly and consistently wired. We will now do continuity tests with the electrical multimeter. As seen, when the two leads touch or when there is continuity, the value on the meter will change. We can see how the jumper wire created continuity between the S pole and the battery pole. We can see how the jumper wire created continuity between the battery pole and the ground pole in the rear. So from these tests, we can see that the continuity between the poles would be at the ends of the solenoid coil. All the other poles have no continuity because the circuit is not closed with an electrical current. Using a rotary tool, we'll then grind the rivets. Once the rivets are removed, the bottom plate will be free. We can see the plate has material on it. This is not only to form a gasket, but also to act as an insulator from the momentary switch. This momentary switch looks like a big washer connected to a cylinder shape. We can see there are springs connected to the bottom of the momentary switch that hold it into place and then return it into position. From this view, we can see the ignition coil pole is connected to the bottom of the switch. This is an optional terminal that is meant to provide current to some ignition coils or ballast resistors depending on the ignition setup. We can also see how the wire from the S terminal is connected to one end of the actual solenoid coil winding. When loosening the I pole, the momentary switch will fall free. We can then see the inside of the assembly. This includes all 5 poles from inside the case. Again, we can see how the springs hold the momentary switch in place and then it returns into position. With the switch and posts out of the way, the actual solenoid or coil winding can be removed. You will also notice the solenoid or the coil has a second wire going to the rear ground post. You'll notice the solenoid is insulated from the top metal piece and mounting bracket with its own plastic case. By squeezing the momentary switch with the springs, we can see the motion that happens when the solenoid coil becomes an electromagnet. It attracts the momentary switch upward into position. So although I've seen more 4-pole starter solenoids, I thought it would be interesting to show this 5-pole since it was previously installed on the Ford 9N tractor project. These starter solenoids are also common in old 12-volt automotive vehicles. As I make new videos, I want to share them with you, so subscribe now. Also comment, like, and check out some of the other content on our channel.